Electrons are negative particles orbiting the nucleus. These tiny subatomic particles are fundamental to understanding chemistry and how atoms interact with each other. Electrons are subatomic particles, meaning they are smaller than atoms themselves. Each electron carries a negative electrical charge. They move in specific regions around the positively charged nucleus at the center of an atom. Most importantly, electrons determine how atoms bond with each other and control all chemical reactions. Let's look at the key properties of electrons. The charge of an electron is negative 1.602 times 10 to the power of negative 19 coulombs. This is called the elementary charge. The mass of an electron is incredibly small, just 9.109 times 10 to the power of negative 31 kilograms. Electrons are represented by the symbol E with a minus superscript. Finally, electrons are considered point-like particles, meaning they have no measurable size. Electrons don't just fly randomly around the nucleus. Instead, they occupy specific regions of space called orbitals. The nucleus at the center has a positive charge, while the negatively charged electrons are arranged in shells at different distances from the nucleus. This organized distribution creates the structure of every atom. Electrons are arranged in shells, also called energy levels. Shell 1, also known as K shell, is closest to the nucleus and has the lowest energy. It can hold a maximum of 2 electrons. Shell 2, or L shell, is the second energy level and can hold up to 8 electrons. Shell 3, the M shell, can accommodate up to 18 electrons. Shell 4, called the N shell, has higher energy and can hold a maximum of 32 electrons. Each shell farther from the nucleus has higher energy and greater capacity. Valence electrons are the electrons in the outermost shell of an atom. These are extremely important because they participate in chemical bonding. Valence electrons determine how atoms bond with each other and control the chemical reactivity of elements. They define an element's position in the periodic table groups and influence how molecular structures form. Understanding valence electrons is key to predicting chemical behavior. Electrons behave in several important ways. First, electron transfer occurs when electrons move from one atom to another, forming ionic bonds. Second, electron sharing happens when atoms share electrons, creating covalent bonds. Third, the movement of free-flowing electrons enables electrical conductivity in materials like metals. Finally, when electrons jump between energy levels, they can absorb or release energy, producing light and color. This explains everything from the colors we see to how electricity flows. Let's recap the essential points. Electrons are negatively charged particles that orbit the nucleus. They occupy energy levels and shells with specific capacities, following a structured pattern. Valence electrons in the outermost shell determine chemical properties and bonding behavior. Electron behavior explains chemical reactions, electricity, and even light. Understanding electrons is fundamental to mastering chemistry and explains how matter interacts at the atomic level.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.